IOE 413, Mathematical Preliminaries Study Guide. Let's begin by reviewing the concept of linear independence of columns of a matrix. Consider the matrix A, and it has columns A.1, A.2, up through A.n when there are n columns in the matrix. So the columns of this matrix A are linearly independent if and only if the only solution to AX equals 0 is x equals 0. Problem starts out with a statement that there's some set S, and it is defined to be the set of all x such that AX equals B. And we also are given that P and Q, which are vectors, are elements of S, and that P and Q are distinct. They're not equal to each other. Now, these two statements have some interesting implications that we will want to use. P and Q and S simply means that A, P equals B, and A, Q equals B. And P not equal to Q means that P minus Q is not equal to 0. These will be very useful to us. Let's begin the problem by just defining a new vector. Just do it by construction. We'll do proof by construction. We will construct this new vector P minus Q and call it V. Pre-multiply both sides by A, so we get A V is equal to A P minus Q. Distribute A through and we get AP minus AQ. But if we look up here, AP is equal to B and AQ is equal to B. So both of these are equal to B. So we have B minus B. Of course, B minus B is 0. So what we get is A V equals 0. Now let's also consider V over here. V is P minus Q, just writing down the exact same thing we had over here. Constructing V is the difference between P minus Q. And note, wow, look at that. Voila. P minus Q is not equal to 0 by what we're given in the problem. Since P minus Q is not equal to 0, V is not equal to 0. And wow, these boxes are a little bit off. But you know what I'm trying to get at here. I'll just draw them over here. And we will write down V is not equal to 0. And A V equals 0. But remember, in the last screen I showed you that the columns of A are only linearly dependent if the only solution would be AV equals to this only solution to AV equals 0 would be V equals 0. That's what would be required for the columns of A to be linearly independent. Since there is a solution here that's not equal to 0, that satisfies AV equals 0, the columns of A are linearly dependent. And that's the answer to this problem. And we have constructed a proof of that.